Hello. In this episode, we're going to talk about the graph of some rational functions. Recall the graph of f of x equals to 1 over x in the previous module number 6. We have determined that the domain is all real numbers except 0, and the range is all real numbers except 0. So the 0 cannot be in the range. As a result, we can see that from the graph, we can see as x getting larger and larger, 1 over x will never be equals to 0, but it can get infinitely close to 0 in both directions. So if you look at this as x getting larger and larger, say 1,000, right? So 1 over 1,000 is a very, very small number. It's closer to 0, but it will never be 0. And in the other direction, we have the same thing. So, and this caused the x-axis to be a line that the curve will never cross. And we call it horizontal asymptotes, okay? In the other direction, we have the domain x cannot be 0. So when we assume x, when we take the value for x, we can get infinitely close to x, 0.1, 0.0001. And as a result of 1 divided by, say, 0.00001, we have a very large value. So the function value gets infinitely larger as we choose values infinitely close to 0 from larger than 0. In the other direction, as x getting closer to 0, the function value will get infinitely small. Say if we choose x equals to negative 0.000000001, and then the function value, which is 1 over that very small number, is getting really, to be, say, negative a trillion or something. So it gets really, really small. So as a result, we have this 2 very special lines we call horizontal asymptote and the vertical asymptote. So this is where we have asymptotes in the graph of some rational functions. All right, so let's look at these graphs, okay? So suppose we put these asymptotes and we mark these asymptotes. Okay, the horizontal asymptote is y equals to 0. And we're gonna mark it by, so we're gonna add this 0. So suppose I'm using green and it's a broken line and I'll make it just a little bit thicker. So this is the horizontal asymptote. A horizontal asymptote means the curve will never touch, but get infinitely close to it. And the vertical asymptote, which is the y-axis, right here, we make it red. And this line is where the curve will never touch because x can never be 0. If the curve ever touches, that means x is 0. But our x can never be 0. The input can never be 0. So we have this horizontal asymptote and vertical asymptote. The equation of the horizontal asymptote is y equals to 0. That's the x-axis. The equation of the y-axis, which is the vertical asymptote, the equation is x equals 0. So with that said and done, and we recall the points we have plotted graphing this rational function, let's look at some other scenario. Okay, now the first situation we want to look at is 1 over x and 1 over a negative 1 over x. We know this is just a reflection, right? From the points perspective, if these are two different functions, for the same input, the output are opposite. For the same input, the output is opposite. So from 1 over x to negative 1 over x, this piece is going to flip over, become the red piece, and this black piece is flipped over to the other side. From the table's perspective, that we will have for if the output is, if the function, the rule of the function is negative, and all of these for the negative input, and all of these will become negative output. Negative will become positive output. Sorry, positive output. Okay, so if it's a negative 1 over x, and this all become its opposite. So it's the opposite reciprocal of the input, okay? Because that's the rule of the function. And the points will become, let me make this a negative sign there. Okay, so this will become positive. This will cause this piece flip up, become the red piece. For the same reason, when we look at the other piece, right? When x equals 1/3, 1/2, for negative f, for f of x equals to negative, okay, which is here. When this rule of the function is changed to be negative, and these will be negative. So these will be negative. So you can see for the same input, the output, for the same input, the output will be the opposite. Therefore, the black piece will flip over. As a result, you can see that the curve, that this black piece, I'm sorry, I'm gonna use the black. Okay, I'm gonna use this black piece, okay? This black piece, there are two pieces for 1 over x. For 1 over x. And the red piece would be these two pieces. And that will make the curve of negative 1 over x. Horizontal asymptote, the horizontal asymptote stay the same, and vertical asymptote stay the same, i.e. for negative 1 over x, the horizontal asymptote, so I'm going to write it down. For negative 1 over x, the horizontal asymptote is still x equals to is still y equals 0, the x-axis, and the vertical asymptote is still x equals 0. Okay, so we can still see that the horizontal asymptote, vertical asymptote stay the same. So if I would graph it, that for the horizontal asymptote, which is the broken line, okay, is shared by these two functions, and the vertical asymptote would still be shared by these two functions. There. Okay, so let's look at some other rational functions. So we clean this up, and we're going to continue to discuss some other rational functions. These three functions we have addressed, which is the shifting of 1 over x, shifting up and shifting down. Okay, so the three functions in consideration is that the black one, okay, the black curve is still 1 over x. The green is 1 over x plus 1. The red is 1 over x minus 1. So we can see this is a shifting of these three, the shifting of the black up by 1 unit and shifting the black down by 1 unit, we get the red, right? The horizontal asymptote get to be shifted. The vertical asymptote stay the same, okay? So let me make just a little bit adjustment here. Okay, so I'm gonna make a table to address these related issues, okay? The black is 1 over x. Okay, the black is 1 over x. And the green, I'm gonna put it right here. The green is right here. And the red is right here. Okay, so we have these three curves. And if you look at the horizontal asymptotes here, okay, so let me make another column. Okay, and the horizontal asymptote. Okay, the horizontal asymptote of the black, of course, is still y equals to 0. The green has been shifted up because the green is 1 over x plus 1. The entire curve is shifted up. Therefore, the horizontal asymptote becomes y equals to 1, which is the green right here. The red, the horizontal asymptote will be y equals to -1 because it's been shifted down by 1 unit. So everything is shifted down. There's no horizontal movement. So the vertical asymptotes stay the same. So vertical asymptotes stay the same. Which is x equals 0, x equals 0, and x equals 0. Okay, so now let's look at the shift of left or right. Okay, these are the three curves that we have addressed in the previous module, which is transition, which is shifting left or right. Okay, in this case, we're gonna still we're gonna bring this table here. The black is still 1 over x. The green is 1 over x plus 1. The red is 1 over x minus 1. Okay, and let's look at the asymptotes. Okay, you can see that the green is the result of shifting the black 1 over x to the left. Okay, the black is shifted to the left by 1 unit. As a result, the vertical asymptotes has been shifted. So the vertical asymptote will become, this still x equals 0, that's y equals to 0, okay? the vertical asymptote has been shifted. It become x equals to -1. Okay, so the green line, the green broken line is shifted to the left. That's the vertical asymptote for the green, and the horizontal asymptote stay the same. Horizontal asymptote stay the same. Okay, so I'm going to use a purple color to indicate the horizontal asymptote, which are the same for all of them. The red one, okay, and the horizontal asymptote stay the same. Okay, so y equals 0. They all have the same horizontal asymptote. Vertical asymptote for the red, which is a consequence of shifting 1 over x to the right by 1 unit, is going to have a new vertical asymptote, and that's going to be x equals to 1. So this is just to summarize of the transitions. If we have these simple functions and we know how to transit, and of course we also can identify the domain. The domain is addressed in the previous module, in the previous topics. Okay, so let's look at another function. Let's look at another function. Suppose that we have a function which is a rational function. Okay, suppose we have a 2 over x minus 2. 2 over x minus 2. Okay, and you can see that this is going to be a shifting to the right by 2 units. Okay, and there's a 2 there, so there's some kind of stretching. Okay, so let's look at the picture. Okay, so I'm going to show you, right? So first you have we identified that the shifting is going to be horizontal shift. And then there's going to be a vertical asymptote, and the vertical asymptote is closely related to the domain. Okay, so we know the domain. Okay, domain should be x cannot equals to 2. And the vertical asymptote is going to be x equals to 2. Is going to be x equals to 2. In graph, this will be shifting. Okay, so if we look at 1 over x here, right? This is going to be 1 over x. Okay, this is going to be 1 over x. So we have this basic graph here, right? So we start with 1 over x. One over x. And then when we shift, okay, to be 1 over x minus 2, and this is going to be shifting to the right by 2 units. By 2 units, okay? So this is still 1 over x, but we're going to graph 1 over x minus 2. So this is, say, make it a green. There, shifted to the right by 2 units. So the vertical asymptote is being shifted. The vertical asymptote before, that was, that was the y-axis, which is x equals 0. And then, of course, we're going to multiply by 2. We're going to multiply by 2. Okay, when we multiply by 2, it's not going to change the domain. The vertical asymptote stay the same. So let's draw the vertical asymptote here. Okay, the vertical asymptote is going to be okay, let's see. Okay, the previous vertical, the 1 over x, the vertical asymptote, let's draw that so we can do a comparison. Okay, 0, 0, 0, 100. Okay, so that was still our vertical asymptote. okay? Horizontal asymptote, we're gonna draw later. So here, that's the vertical asymptote that comes with us. Okay, so that vertical asymptote that was for 1 over x now is shifted because 1 over x is shifted to the right to get the green. We get 1 over x minus 2. The vertical asymptote now is going to be x equals to 2. X equals to 2 now. So that represents a shift to the right by 2 units. When the entire graph is shifted to the right, the entire graph is shifted. How about the horizontal asymptote? The horizontal asymptote stay the same. You see, there's a horizontal asymptote stay the same. Okay, so what if we multiply by 2? When we multiply by 2 for the same input, the output is going to be even larger. So the curve is only going to getting closer to the asymptote sooner. And therefore, if we multiply by 2, the consequence of this transition, okay, so after we graph the final picture, which is 2, you're going to see that it's going to be rather similar. It's going to be rather similar to the green. Okay, it's just going to reach to the higher sooner. Okay. All right, so this is an example of the rational function. For other rational functions, most of them will be the, if there's a situation similar to that situation, we're gonna have just a shifting either up and down or left or right. And in other situations, for example, okay, let's take a look at another. Suppose we have a 1 over x squared minus x minus 2. This graph, we have to first decide this graph from determining the domain. The domain would be, we need to require that the denominator cannot be 0. If the denominator cannot be 0, it's a factor form. Cannot be 0. And as a result, x plus 1 cannot be 0. And x minus 2 cannot be 0. To guarantee the product cannot be 0. So as a result, that we know that x cannot be equals to -1, or and x cannot be equals to 2. So the domain will be all real numbers except -1 and +2. So that's the domain. With that domain, we will know, I'm sorry, this is not equals to 2, not equals to 2. And we will know that there's 2 vertical asymptotes, 2 vertical asymptotes. So the curve will have 3 pieces. We'll have 3 pieces, okay? So when we graph this function, okay, we'll see 3, wait, that's not right. Okay, so I'm going to just graph that one, okay? So it has 3 pieces, These 3 pieces are, okay, these 3 pieces are in 3 intervals, there's a vertical asymptotes and there are horizontal asymptotes. Okay, so let me adjust the view just a little bit. -5, +5, and y make it -2, 2 +2. So see what that picture would do. Okay, so there's a vertical asymptote. There are 2 vertical asymptotes. Okay, so let's graph these 2 vertical asymptotes. One is a -1, and the other one is x equals to 2. So there are these 2 vertical asymptotes. Okay, maybe I should make it red. Broken line, medium, and there's another vertical asymptote, which is going to be 2, x equals to 2. Make it red, broken line, medium. Okay, so these are the vertical asymptotes. And in between, then you say, how would I graph it in between? You just plot some points. But there are some clues as to help us to graph it. For example, we will know that you're going to graph from these 3 intervals. Okay, smaller than -1, larger than 2, between -1 and +2. Okay, and so when we actually plot the points, we'll plot some points between in each interval to get the function. You can see in this case, once you have determined the vertical asymptote, the horizontal asymptote is rather obvious. It's rather obvious, right? It's, you know, it's the vertical asymptote. So let's write down the vertical asymptotes. Okay, the vertical asymptotes are x equals -1, x equals to 2, and the horizontal asymptotes is just going to be y equals to 0. Okay, there's some gap in between. There's some gap in between, and we will leave these topics for your future courses. I think for your trigonometry, knowing these is sufficient. Thank you for watching.